We have read particle in a box in previous lecture. In that we have derived eigenfunction and eigenvalue corresponding to that particle. Just recall, we have taken infinite height wall, distance between them is L. There is a particle having mass m and velocity v. For this particle, since it is moving particle and there is a wave packet associated with every moving particle, so we have found expression of wave function, which is under root 2 by L sin n pi x by L. As well, energy value, eigenvalue n square pi square h cut square upon 2m L square. These are constants, so En proportional to n, that is En is quantized, where the value of n is 1, 2, 3 and so on. N is equal to not 0, because for n is equal to 0 wave function will be 0, which is not admissible. Now if n is equal to 0, psi is 0, it means that probability of finding the particle is 0. It means that there is no particle in the box. So it is clear that we will not consider n is equal to 0. Now for lowest energy level, for n is equal to 1, we have E1 1 square pi square h cut square upon 2m L square. H cut is equal to h upon 2 pi. So we can put this value, pi square will be cancelled out, because h cut square is h square upon 4 pi square, pi square h square upon 2m L square into 4 pi square. So cancel out this pi square. What we get? H square upon 8 m L square. This is E1. This E1 is called 0 point energy. So we have shown EZP. This is called 0 point energy. Of the particle. It means that particle has energy even at 0 Kelvin. Okay. Now proceeding further, we have derived, as I have said in previous lecture, psi n. So we will consider for wave function now. So using that equation, we will write down psi 1. Now what is psi 1? Psi 1 is under root 2 by L psi 1 x under root 2 by L sin pi x by L, as same psi 2 under root 2 by L sin 2 pi x by L, psi 3 under root 2 by L sin n pi x by L. So, these are wave function value and so on. We can increase for no problem, but we will consider, we will learn something from these examples. We can find out psi 1 square, as we know that in case of physical significance of psi, psi has no physical significance, while psi square implies the probability of finding the particle in region. So, we will consider now for probability, this will be 2 by L sin pi x upon L square, as same for psi 2 we can write this expression for psi 3 so what we are finding? We are finding probability of finding the particle in these allowed energy states. It is for n is equal to 1, n is equal to 2, and this is for n is equal to 3. This would be 3. Now, we will show graph of these wave function as well graph of probability. So, now look over some graphs. As we have seen that value of n is equal to 1 implies psi 1 x is equal to under root 2 by L sin pi x by L. As we know, there is limit of x is equal to 0. For x is equal to 0, this implies psi 1, this is obviously 0, sin 0 is 0. For x is equal to L, at endpoints L, when you will put here L by L will cancel out, again sin pi 0. So, again for at x is equal to L, again psi 1 L is 0. What is the value when psi 1 has maximum? In that case, consider x is equal to L by 2. In case of L by 2, what we find? L. So, L by L cancel out, pi by 2. It means when you will solve this one, psi 1 of L by 2. So, under 2 by L sin pi L by L into 2, L cancel out, sin pi by 2 90 degree, it means under root 2 by L. So, this psi has maximum value at midpoint. Okay. So, for this we can plot graph how it looks like. Look here. Now consider this is x is equal to L and this is x is equal to 0, and this is considered as, yes, exactly, amplitude under root 2 by L. So when we plot for psi 1, this will be as here x is equal to L by 2. It means here psi 1 has peak value. So you will find like this. This is for psi 1. Now consider for psi 2. When you will consider for psi 2, what you will find? Look here first again. For psi 2, just above again, this expression is psi 2x sine 2 pi x by L. Now we can find its value here. For x is equal to 0, you will find obviously psi 2 is 0. For x is equal to L, sine 2 pi sine 360, again sine 2 at L also 0. Now find out at midpoint. At midpoint, when you will put L by 2, so L by 2, L cancel out, 2 to cancel out, sine pi will remain again 0. This means psi 2 at L by 2 also 0. Now we have to find where it is maximum. For that, we will see for x is equal to L by 4. For this psi 2 L by 4, this is what? Consider here, you will get under root 2 by L sine 2 pi L by 4 into L. So L cancel out, 2 to the 4, so pi by 2 means 1. This means that for psi 2 at L by 4, it has max value which is under root 2 by L. As same, you can find for 3 by 4. So for x is equal to 3L by 4. Again find out. So psi 2 will be under root 2 by L sine 2 pi, in case of x this is 3L by 4, and here L also, L cancel out, this is 2. Now sine 3 pi by 2. So what we get? Clearly this is minus 1. So minus under root 2 by L. It means this will show negative amplitude. So in below figure, for psi 2, what we form, just look, we will form here negative region also. Now this point is L by 4 and this point is 3L by 4. So when we will plot we will get here max amplitude as from above equation, and here 0, here 0, here max, and here 0. Now join it, so we get as like this. So this is the representation for psi 2, while this is of psi 1. As same, we can solve for psi 3, and it will be, I can draw it now, you can see by yourself. As we know, psi 3 is what? Under 2 pi by L sin 3 pi x by L. So after solving, what you get? We will get at x is equal to L by 3, and consider one mode point, 2L by 3. Okay, so now what we find out? At these points, that is L is by 3 and 2L by 3, psi 3 will be 0, and at L by 6 it will max in positive sense, and just half of it negative sense, max value, and just half of it again max in positive sense. So we can draw now freely. Now drawing for psi 3 like this, a smooth curve will draw. So this is for psi 3x. So as you will increase for wave function for fourth n is equal to 4, there will be more complexity. So what we infer that these are the nodes, these points are nodes in that for that value of n. Okay, now we want to see a graph for probability of finding the particle in corresponding energy states. Obviously this is minus under 2 by L, which is amplitude in positive sense, and this is also amplitude in negative sense. Okay, so now come across a graph of probability of finding the particle. This is for mod psi square. So for probability we will use mod psi 1 square. So for n is equal to 1, what we have seen, the value of psi 1x is under 2 by L sin pi x by L. So we will get a square here under 2 by L square sin square pi x by L, and obviously since there is a square, so probability will be positive and there will be no negative amplitude. Solve it just, this is 2 by L sin square pi x by L. Now consider probability will be maximum at, yes, at x is equal to L by 2. This mod psi 1 x square will be, because here L by 2, so sin square pi by 2, this is positive, that is plus 2 by L. This is max value. It means that At this point, the probability of finding the particle for n is equal to 1 state will be maximum, whereas for x is equal to 0 and x is equal to L, if you will find psi, this is L by 2, 0, as we have solved also just in previous case, in case of psi graphs. So obviously 0 minimum value, and also at x is equal to L, this will implies 0 value. So we can see the probability of finding the particle at x is equal to 0 and x is equal to L will be 0, whereas at L is equal to, at x is equal to L by 2, it will be maximum. So we can plot graph for probability. Just look here. For this, we will draw again. So we have drawn in case of particle in a box figure. We can draw for better understanding like this: 1 0 point L. Now, when you will see for psi 1 x square, this is for probability, the probability of finding the particle here is 0, here is also 0, but at x is equal to L by 2, this is maximum. So for probability you will get curve like this. This is for probability. So this is represents psi 1 x mod value square. Again you can find out psi 1 x square okay. Now for second reason, as we have solved for psi 2 x also, and we have seen that at L by 4 and at 3L by 4 psi 2 has max value, but there was positive amplitude and negative in case of psi 2x, but here we are finding probability, so that negative since amplitude will be positive here due to square term. So again we will find for psi 2, so this will be like this. You can draw here for a length scale diagram just here, and what we find that here is maximum, so here is will be peak value, here at L by 2 again no note, at here is called 3 by 4 again this one. What we want to show at for this one max probability at L by 2, and for psi 2 max probability for L by 4 as well as for 3L by 4. So this is for psi 2 x. As same we can increase for psi 3 also. So as you will increase, what you will find, number of nodes are increasing. Here 2 nodes, here 3 nodes, yes, at 0, L by 2 L. Again in third case you will find obviously 4 nodes there will be. So as energy is increasing, as height is increasing, the probability of finding the particle will be lesser. This is what we want to conclude from this graph. One more thing I want to show. What we have discussed here, this is according to quantum mechanics, or this is now probability. Obviously this is probability. So for here, if you will see this green line, showing classical view. Yes, in classical view, the probability of finding the particle is shown by this green line, but according to quantum mechanics, at all points there is different probability of finding the particle. So this is what we differentiate from classical mechanics, and we get a more and accurate knowledge using quantum mechanics. So this is what we have considered particle in a box. Thank you.